Okay, Assalamualaikum and a very good morning to you all. My name is Dr. Humaizi bin Hilmi. Today, we are going to continue about the deflection consideration. Okay, I take this note from the chapter 7, shaft and shaft design. Okay, from the book Shigley Mechanical Engineering Design. And all the images I take from for this slide is taken randomly from Google Images. So, to calculate a shaft, deflection analysis of a shaft, you require information for all the point in the shaft. Okay, this is, let's say this is shaft, you want to calculate all the point you must calculate. Okay, this is the problem when doing the shaft calculation. And for the simplest idea is you first calculate at the point of contact first with the gear, shaft and pulley. Let's say is this clamping point is the point of contact with the shaft, bearing, pulley and flywheel and everything. Okay, you calculate this first and then you calculate all the shaft design, shaft diameter and everything at all other points. This is also challenging, and it is suggested if you have a software, better do with help from software. For initial analysis, you can do calculation. Okay. Okay, so we want to do the deflection. Just like I said before, calculate first at the point of contact with the gear and bearing and all other things that is connected with the shaft shoulder. Okay, so the reason is, let's say this is the shaft bearing. Okay, my hand is a shaft bearing. Okay, when I put the load, the deflection happen here first at this point first. Okay, so we don't want to this to be allowed. Okay, so this is the reason you want to calculate this first, because if this point fail, everything is fail. Okay, so the typical ranges for maximum slope and transverse deflection. Okay, you see here, this is the table point 2, the typical range for maximum slope and traversification. This table is given by in the book. From the experience of the designers, they come with this table. Okay, meaning that basically you have this table, you have this shaft. Okay, the shaft is clamped with the bearing. Okay, this is a bearing. Let's say this is a bearing. Deflection for the shaft, you do not want it to become so deflect. Okay, the value is in radian. Okay, so if it deflect, it defeats your purpose to do the design. Okay, you want to avoid this deflection. Okay, okay, beam deflection method. As you remember, in the last semester, you have learned in mechanic of material class in the deflection in using the book Hibbeler book. Okay, the textbook from Hibbeler. Okay, chapter 12. This deflection of beam. There are 4 methods. Okay, they are superposition, the moment area method, the singularity function, and numerical integration method. Okay, if you are if you are familiar with this topic, it's good for you. If you are not so familiar, I suggest you read in chapter 12 in Hibbeler book. Okay. Okay, student, don't be afraid, because nowadays there are many software that can help you. These 3 software is mentioned in the textbook Nastran, and SIS, and Algor. And sure, there are many software, uh, maybe is better than all the software. You can use whatever software that is user friendly to you. Okay, this is all the software that will help you doing the calculation. Okay, but the principle behind the software, you must know how to calculate basic. Then, because when you do when you put your input in software, you can get any result. Okay, what the meaning of the result? That is what you must learn from the class. Okay. Okay, deflection they is larger than allowable deflection. First of all, what is deflection? Okay, let's say this is your shaft. This is your shaft. This is clamp. Okay, this is what clamp. Okay, when you this is a hanging a cantilever shaft, you put a load here, a load. Okay, and then it deflect. Okay, it deflect. This is deflection. Okay, this is deflection. So if the deflection is larger than your allowable deflection, you have to increase the diameter. The diameter increase the diameter. Okay, and also if you if the diameter cannot be increased, you should use a materials stronger have stronger strength from the previous material. Okay, because it is related to the moment and also the moment of inertia. And remember from the moment of inertia equation, I mc per I, okay, stress equals to mc over I, which I is the moment of inertia, which is moment of inertia is related to the to the Young modulus of the material itself. Okay. Okay, what about the slope? What is a slope? What is different from slope and the deflection? Okay, this is deflection. Okay, this is deflection. Let's say this is a shaft, I put a load and this deflect. Okay, this deflect, the range deflection is the deflection. The slope is the is is m, is called by this is the slope. Okay, this is the point of the slope. Okay, this is called the slope. Okay, again, if you want to repair the slope, you should increase the diameter, and also maybe you have to change the material from the shaft, make it a stronger material for the shaft. Okay, how about the shear? How about the transverse shear? What is a transverse shear? Suppose it to be this is a shaft. It's clamped with two bearing here and here. Okay, it's clamped by two bearing here. When you put a load onto the shaft, okay, the load onto the shaft, it will deflect. Okay, it will deflect the shaft. Maybe it become like this. Okay, because of the shear effect. This is a shear. Okay, this is what you clamp. This is the point that you clamp. Okay, become a shear. Okay, so what is allowable shear? This is what you want to is only allowable 1% of the deflection. If beyond 1%, you have to redesign. Maybe you have to increase your diameter. Okay, increase the diameter, and also maybe you have to make it the clamp one shorter. Okay, instead of longer. Okay, make it a shorter one. Okay, the clamp. Maybe you can change the material property from the for the shaft and everything. Okay. What is the mean by shaft to length to diameter ratio? Meaning that this okay. The length, this is the length of a shaft. Okay, length of the shaft, length. Okay, this is the diameter of the shaft. Diameter of the shaft. So if the length if length, let's say the length is L equal to 10 meter. Diameter equals to 1 meter. Okay, centimeter or meter, if you, let's say lah. Then you meaning that the shaft is long lah. L over D equals to 10. If the ratio is below, if ratio below 10, then the deflection is taken into consideration because it may be deflect. Okay, it may prone to deflection. Okay, where do you see this kind of thing? Okay, if you're going back to your hostel, okay, the hook that you put, okay, your clothes on, this is a hook that you put your clothes. You put your clothes, okay, when you go back, when to wash your clothes, you hang your clothes here. Okay, you this is a hook. Okay, the hook, the length is small, the short length is short, and diameter is also short, meaning that it will give stress, more stress at this point and more shear at this point of contact. Then this is taken into consideration because this hook or any other things that is meaning that the shaft is short, it have a tremendous load on it and it may broke. Okay. Okay, how about a shaft in torsion? Okay, shaft in torsion meaning that the shaft is in moving. Supposed to be the shaft is an axle of a car. Okay, supposed to be shaft supported a pulley. Whenever a pulley is moving, it give some torsion to the shaft also. Okay, then this is what you want to calculate at some point of time. Let's say this is a cardboard. If I give a torsion to it, the cardboard will break away like this. Okay, so it will happen to the ductile material also. If given excessive load, it will break. Okay. Okay, in the previous slide we discussed about the torsion and how about the torsion stiffness. Okay, you see in my last example, I give a example of this cardboard. This cardboard is already broken away because I give excessive load to the cardboard, and this cardboard broke away. Okay, how about sturdy material, hard material like this, like my water bottle. Okay, it is difficult to me, hard to me, for me to make it torsion, make it damage, because my hand cannot move it. Okay, my hand cannot make it damage. If I use machinery, it may damage. Okay, but for this cardboard, because my hand have more power, more strength than this cardboard, it broke away. So this is called the stiffness. Okay, this is called the stiffness, meaning that basically it means that the property of that material to make it stronger, make it hard to break away. Okay, so that's the end of this video. We see you in the next video, and the next video we are doing some example. Okay, goodbye for now.